Welcome to video number 1 of the Zero to IB Hero series. In this series, I'm going to show you how to master every single topic in order. Who am I to do this? I'm a professional tutor. I've delivered over 2,000 sessions to many different students. I've helped dozens of students in your position get top grades, right? Basically, I've helped not only people in your position, I've helped many of them get the results, okay? And I'm going to show you how to do it for free here, okay? Starting with Sequences series, the way that we do this is that in the first video, I'm going to go through the basic theory. I do 80-20 theory. What I mean by that is I'm not going to cover everything, right? I'm going to go through the 20% that has the 80% results. Does that make sense? The 20% of the content that has 80% of the results. So I'm going to go through the basics, and then we're going to do another 3 videos increasing the difficulty. Video 1 will just be easy, medium, and then easy. Then video 2 is medium, video 3 is harder ones, yeah? So depending on what you're trying to do. If you're looking to get a top grade here, then you should do all 3 videos. It won't take you that long, right? It takes you, 2 days to watch all of this. There you go. You've just had, a bit of a masterclass on that topic, okay? If you just want to pass it, then just go through the easy ones across everything and you're set, all right? Or you could just watch these 80-20 videos as a recap on the theory, okay? So in this one, we're going to jump in Sequences series, right? This is one of the easier topics. We're starting with Maths AAHL. And within this, we have basic questions, so basic geometric and arithmetic questions. Of these, we have 2 core different types. The 2 core types that we have are we have finding an nth term or the sum of n terms, and it's identical for the same for both of these. So having a good grasp of the formula booklet will be helpful here. And now you do not need to memorize any equations. You just need to be aware of what is there, okay? All right? Then after that, we're going to go through sigma notation. Many students get very intimidated by this. It is literally just writing out the same thing as geometric and arithmetic, right? And we just have to be a little bit logical with the steps. And the last one is interest rates, right? We have interest rates as well. Oh, and one more I forgot as well. Geometric, we have the sum to infinity, right? Which it isn't hard, it's just an extra little add-on. And last one is interest rates, so basically like financial maths, okay? So let's go through them in order, right? So to find an nth term, basically, in summary, guys, to find all of this, all you need to do is know the first term and the common ratio. And if you don't know what language I'm talking, right, I'm going to go through the real basics right now. In a geometric and arithmetic series, right, we have a list of numbers, right? Numbers one after each other. Arithmetic is that the thing that is connecting each term to the next is a common addition. Example, 1, 2, 3, 4. Every single time we're plus 1. If I did 1, 4, 7, 10, every single time is plus 3. This is our common difference, our common ratio, right? Now, specifically, this is difference because that's what they use in the notation for arithmetic sequences. But the idea is that this is what connects it, just like a ratio does. Now, in terms of geometric sequences, this is where we have the ratio. 1, 2, 4, 8. We're timesing it by 2 each time. Does that make sense? This is our common ratio. This is the thing that connects it. This isn't hard, right? It makes sense. So as long as we know these 2 things, we know our first term, and we know the common ratio, the common difference, we can practically solve all of this, okay? As a general tip for maths and physics, if you start thinking of these problems as just a list of variables, how many there are, then it starts to become a lot easier on how to solve these. So for a lot of these questions, for example, let's take for the nth term. There's only really 1, 2, 3, 4 variables here, right? If we know this one and know this one, then all we need to do is choose our n value. Well, like if we want to find our 7th term, which n is 7, right? Then we can find the nth term. That's it, right? So when you create a list of variables that need to be found, it's much easier, okay? Right, now, I'm not going to go too deep into the equations, but essentially everything is there. And you do not need to memorize them, but you need to do questions so you get used to using them, okay? I'll go through them really quick. For the nth term of an arithmetic sequence, right, it's just, this one here. We just have our first term, our common difference, and our n value. Our n will tell us which term. If we want to find, like I said, use 7, then n equals 7. There you go. That's how you draw 7. Okay? Right, then we have our sum of n terms. To find the summation, it's the exact same idea. Right? We have our u1, we have our d, and then we just have to select our nth term. That's it. The sum of 7, you make it 7. Now, they do also have another option where you have un. They have un, right? Notice, if you wanted to try this out, un is this. If you substitute all this in here, you actually just get this equation. It's the same thing. Okay? Right? But, okay. Now, that is all you need, is recognizing that. So essentially, we have one equation where we do it in terms of the final term. Let's say we wanted to find the sum of the first 8 terms of some random sequence. Then all we have to do is find what UA is. And U1, and we got it, okay? All right, let's go back. For geometric, it's the exact same. First term, common ratio, n. Same idea. For the sum of a finite sequence, first term, u1, common ratio, n. First term, common ratio, n. It's the same idea. It's easy, people, okay? All right, and then we're going to go to the infinite sequence. Now, this one is a little bit of theory behind it. In an infinite sequence, right, why is it infinite? That sounds weird. The sum of an infinite sequence. It's because if we keep adding the number, right, it means that at some point we have what is called convergence, right? The numbers, if we keep adding them up, it doesn't increase anymore. And that might feel a bit weird, but let's do a practical example. If I had a sequence where it was, for example, we're starting with 4. The next term is 2. The next term is 1. The next term is a half. Do you see what's happening? We're getting smaller and smaller and smaller until eventually we're basically dividing by an infinitely large value. This approximates to 0, right? And because this approximates pretty much to 0, that means if we were to add these up, the total sum will approximate to 0. Let me say that again, right? Because the terms are getting smaller, eventually the terms are just going to be equal to 0. So if I add these up, then at the end, all of the remaining values beyond there, to infinity, the infinite term, is approximately equal to 0, then it's just going to remain at that value. Now, this is what we call convergence. And the condition is this. They're literally telling you the condition. The magnitude just means if it's negative, turn it positive. So the magnitude of -2 is 2. Yeah? So as long as the magnitude is less than 1, then of course it's going to keep getting closer to 0. All right? Like, for example, here, the common ratio is a half, less than 1. Okay? Then, once you get that, one of the most, like, kind of intimidating, like, sub-aspects of this topic is actually the easiest. Because look at that equation. It's so easy to work with. Okay? All right? Now, sigma notation. People get very scared with sigma notation. Right? Sigma notation is very simple. All you need to do is know how to read it. Okay? On the bottom, we're going to have where we start counting from. Okay? So, for example, let's say we're doing n. We're going to say n equals 1. That's the first one we start counting from. Sigma stands for summation. It's a sum. So we're basically just doing a sum of terms. The value on the top here, it tells you when our upper limit is. Let's say we want to find the sum of the first 10 terms. This is 10. Because what you're going to do is you're going to be adding. So if I put un here, you're going to be adding u1 plus u2 plus all the way until u10. Right? Numbers are difficult. Okay? That would be the summation. That's it. And then this part on the right here is the expression itself. So let's say they gave us an actual function for it. X squared, okay, well, I'll put it in n. So let's say n squared minus 1, right? So let's actually do this. Let's just like take a quick little example and just do the first couple terms. Well, if n equals 1, then it's just 1 minus 1. So when n equals 1, this is 0. When n equals 2, right, this would be 4 minus 1, that's 3. When n equals 3, that would be 9 minus 1, that's 8. Okay? That's what I mean, 80-20. We're just going through the key stuff here. As long as you understand what the summation thing means, then the questions will make more sense, okay? All right? Cool. That is basically it. I wanted to keep this short and sweet because you don't need to know much more than that. All right, and then the last thing we have is our interest rates. Now, the compound interest questions, essentially, you have almost everything you would ever need, especially for some of the easier questions, in the formula booklet. It tells you all the variables directly, right? The future value is the value in the future. Present value is the value in the present. You think this is an English class? Well, then R is the compound interest rate, or just the interest rate. Yeah, so how much is increasing? The nominal annual rate of interest. So how much that increases per year. That's just the interest rate that they tell you. And then K is the number of compounding periods per year. We'll do some practice questions and you see how we use that. And N is just the number of years. That's it. It literally, I'm like reading to you, right? I could be here silently and you'd be getting the same amount of value, right? It's in your formula booklet, right? It's all there. Okay? And then after this, and yeah, here's an actual diagram, which I forgot I put. Yeah, so here we have our lower limit is our first value. Then we have our upper limit, so when I is equal to this, and x to the I instead of, n for our case, right? That'll be it. And it just means summation. That's all this is. Okay? All right. That's the video number 1. That's a basic intro. We're going to go through easy questions, medium questions, and hard questions across all. If you watch those 3, you should be a master of it. Okay, I'll see you over there. Bye.